Thank you. Thank you for being here. Yeah, as you mentioned, I'm Jonas Anderson, Swedish Transport Administration. We have done some research in the near future, in the near past, about evacuation lightnings in smoke-filled tunnels. And that's what I'm presenting today. An introduction. As we all know, tunnels present particular fire safety challenges. And smoke drastically reduce visibility, making orientation difficult. Evacuation lighting should assist under very tough conditions. I'm also going to talk about what the research says about different lighting types and what we have done to implement this in the E4 bypass. And then a little caveat in the end, we have made some material changes. Let's see if any here are familiar with that type of material changes to reduce the CO2 equivalence. Yeah, the role of an evacuation lighting. Yeah, to provide orientation, comfort, and directional guidance. Must function during power failure, so via UPS or batteries or something. If we have a power shortage within a fire, and should guide towards emergency exits and not be confusing. The research that's been made recently for this, I think the one with NordFI expecting smoke was mentioned, but we have done in Sweden, we've done the RISE report and then Lund's Technical University degree project on self-evacuation in both road and railway tunnels, recently published. These all are available online. And what type of evacuation light do occur in Sweden? We have point lighting, LED or traditional spot lights, everywhere from 8 to 25 meter spacing. We have now in the Stockholm bypass continuous lighting, and first project in Sweden to do that. And some older tunnels, and I see a lot of Norwegian and Faroe and Icelandic tunnels use ceiling mounted light as evacuation light. Correct me if I'm wrong. Yeah, and some results from these different tests that have been done, full scale and human nature adaptive research. The caveat of this is lead strips, the height of 1 meter height, are the best choice for orientation and perceived safety. That point lighting up to 25 meters have minimal effect because of the clouding effect of the smoke. You can't see more than a couple of meters in front of you, and if you stand between two light fixtures, you can't see neither of them, and then you're, as they say, screwed. And ceiling lights, in all the tests, the ceiling lights, yeah, we know hot smoke travel to the ceiling where the ceiling lights are, and they are not visible. Then we have also done some orientation in smoke-filled tunnels. This is you can see we have a car that's on fire there. We have the BBS, the fixed firefighting system, on here, but it's also very smoky. And it's like from the picture taken to the first light fixture is like 6 meters, and then the other one is like 12 meters, and then you can't see anything. What we've seen in all the results, that continuous lighting, not the fixed points, are have a clear direction, a clear visibility, and the point lighting are very hard to perceive. What should I do with this point? It doesn't say where I should go. And even in some tests and some tunnels in Sweden, especially the municipal tunnels in Stockholm, city central, the light fixtures are heavy glaring. So the evacuation, the evacuees, and also the road users have a lot of glare and discomfort. They don't want to look at it, and if you don't feel safe with it, you don't use it. We have done a lot of walking speed tests in smoke with theatrical smoke, so of ethical reasons. But we have these 8 meters, 20 meters, and the continuous lead strip. And what we can show here is that the 93% of all the people walked faster with continuous lighting. There's this graph here. So you have some people are making some bad decisions, but if you have 25 meters, it speaks for itself. Oh, sorry. Yeah, and then it's not just continuous lighting. We need to look at the glare effect and where should the light be put, on which height. We looked at the minimum requirements in the EN Directive 1838, escape lights. It said no more than at least one lux among the escape path. Minimum of say 50% of the surface should be illuminated. And we concluded after rigorous tests that somewhere between 270 to 400 lumen per meter directed outwards and downwards are the best results. Some of you probably know Henrik Modig, PIARC, and other tunnel conferences. We've done a lot of SketchUps and mock-ups for this type of tests. We have also put it in a VR simulating model and see how the LED strips compare to fixed light fixtures. And also with the human nature, with all the tactile navigation that the handrail, or if you can see your feet, how it implements in walking speed and such. Yeah, and then to conclude the design recommendations from all this research we have done, that LED lighting strips are the fastest and safest for the evacuation escape time and even the visibility of the light fixture. We have put it on approximately 1 meter. Our Swedish law says over 1 meter, and our own regulation says somewhere between 1 meters and 1.5 meters. So for the bypass, we put it on 1.2 meters. Use non-glare effects with a downward slope and light colors. We've seen that the lighter the higher the, what do you call it, the coloring. What's it called? Kelvin, thank you. The higher the Kelvin, the better, because it's more bluish white than yellow cloudy. We have also seen in all the research that we might need to use more tactile systems, handrails off the walls, and acoustic beacons. That's a new one in Sweden. We've seen that even acoustic beacons can help in troublesome conditions. Then regulation versus reality. Yeah, many tunnels still use lighting with 25 or even more spacing between. And regulations can be either unclear or very outdated. Even the EU directive has some years. And as we can see, research clearly shows continuous lighting is superior in any way in all types of conditions. And from 2024, we have a new Swedish requirement that we can have point lighting and we can have continuous evacuation lighting with a minimum of 10 meter spacing, preferably even less, but that's a max. And then the continuous evacuation lighting has some lumen requirements, angles, and mounting heights. So that's fairly new. And what have we've been doing then for the Stockholm bypass? Yeah, from idea to implementation, we did all the mock-ups, we did all the glare and the lumen requirements, and then we ended up with a aluminum casing. That's not that on picture. And then we started to think, aluminum, 55 kilometers of aluminum rails, quite expensive, quite heavy load. Isn't there any better option? And then we looked into glass fiber reinforced polymer. Yeah, this could work. So we did a mock-up of that and proved very efficient with a LED strip mounted inside. And then we also supplemented the escape routes with strobe lights, acoustic beacons, and dynamic lighting. As you can see on the dynamic lighting is, we have a spotlight that's fixed on the escape portal. And then we have strobe lights on the side and over the escape route. And then an acoustic beacon at the top of that. No, we can't hear the sound. This is a newly implemented test that we did a couple of weeks ago for a small tunnel section of the Stockholm bypass that's going to be open in about a year. And then one loop more in English. So we have Swedish, English, Swedish, English. On the opposite side of the tunnel, on the safe side, where the evacuee have gone to, it's quiet, but when we want them to go back to their vehicles, we also start a message, return to your vehicles. It's safe in both tunnels. We have a quick evacuating of all the traffic so we can open up the tunnel again. And it's after we have inspected all the tunnel. And then you can see the LED stripe. It ends here, but you can see everything. It's like 10 meters across here. If you stand in the smoke, you have like 2 meters, 2-3 meters visibility, but you can see the LED stripe continuously. If we have activated the next section, you have clearly could see that also, but in this picture you can't see it. And we all also tested this rigorously with our cleaning units, so we can see that it holds up to the pressure of the car wash. It's like a big car wash on wheels. It confirms that the housing withstand brushing, and the water and the pressure from the water that is almost high pressure. It's like somewhere 80 to 100 bars if you're very close. It loses pressure quite quick, so it's on the wall. It's like 20 bars, but high enough with a lot of water, and then the car brushes. It didn't detach from the wall. We had some minimal ingress of water, but we tested this so hard. So if it had no leakage, it would be miraculously. So that kind of droplets are fine because it doesn't disturb the lighting. And the light strip inside is IP68, so it's waterproof, so it could be submerged in water if you want to. Yeah, and then the material exchange. As I said, we have 55,000 meters of light strips. 1/3 is installed, and 2/3 are being installed as we speak. We calculated the CO2 equivalent savings from aluminum versus GFRP, up to, depending on how much recycled aluminum that was made. That's not a number that the supplier could share. But if it's 100% recycled aluminum, we saved over 400 tons of the CO2 equivalent versus with the GFRP. And if it's no recycled aluminum, it's raw aluminum, it's almost a double in CO2 savings. And we also saved 16 tons of transport and installation. Someone is going to lift every 5-meter section and put it to the wall. So it's for the worker, it's much easier, much quicker. The rail comes in 5.5-meter sections and are just done automatically via a fixed like pressure chamber, and they made it rapidly. It's cost neutral between material choices. It's the same cost either way. And the glass fiber reinforced polymer can be done with flame retardant and UV additions. UV additions in tunnels, not a concern. We've looked at it in the railway tunnels that are more open and have some railings that are in railway tunnels with UV additions, but the flame retardant, we don't think the light fixture are significant. It doesn't add to the fire load itself from the vehicle, and it's not going to burn. It's going to melt and drop to the floor. And we have also newly, this is like less than a year old, we have approved one standard light handrail in Swedish railroad tunnels. So if a contractor says we're going to use exactly this, we don't need to inspect it. We know exactly the parameters on it. And you have the tactile handrails and everything. We haven't looked into this type in road tunnels yet because it's building too much out from the wall and are going to be driven down by all the bad drivers we have. Quick, non-in-depth, like 10 minutes or yeah. You said to hurry up, so
Yeah, it's 30 minutes. Yeah, 30.
Okay. Questions? Clear as day or confusing as hell?
Must be either.
No? Maybe just one question.
Yeah.
Install these handrails in many tunnels
In railway, the handrail in railways.
or in road tunnels. Let's do so.
Yeah, the lead strips. No, the Stockholm bypass is the first. So we just starting to test it now full scale with all the other safety parameters when it's going to start, when we do when we have an escape plan. Does it start as it should? And also in the Stockholm bypass, the lead strips, the first seconds is going to blink to get the people's notice, and then after a couple of seconds, it's going to be fully lit up.
Are you planning this for other?
Yeah, Stockholm bypass, 55 kilometers now. The first part of the tunnel that's going to be open in a year, like 1.8 kilometer tunnel that's free from all the rest. So we're going to open that in a year, and that has it. The whole southern part of bypass Stockholm. The other 50 kilometers has it. It's been installed now, and then we have another project when the bypass is done. We have 3 more tunnels, smaller, 1 3 kilometers and 2 1 kilometer tunnels. That's going to have this type also.
I have one. Would it be possible to install this on an uneven, plastic?
Yes, because our wall elements in the bypass has some centimeters not lining up to one another. So the back bracket has okay. Here we need 1 millimeter spacing. Here we need 5 centimeter spacing. So you want the light to be continuously straight line, and if the wall is wobbly, then you use brackets. So the line is steady, and as far out so you can use it as a handrail also. So now you just put your hand on it and guide yourself.
Any more? No. Well, thank you, Jonas.
Thank you.
Thank you.